weather and climate, since maybe in your first year bachelor degree, we already know about these two different what, and also what is a climate change. Nowadays, uh, most of the teenage and the junior student already know about this war by scientifically, and also the difference between our global warming and climate change also. And here I would like to highlight one thing only about the global warming and climate change. These two words are actually totally different because climate change, I think science student already understand about. So climate change is actually the nature process. Our nature is changing by one momentum of our uh, galaxies rotation and the sun other solar system impact. According to the solar system impact, the climate is already changed itself slowly. But due to the global warming, which is unprecedented, otherwise our human causes, the global is warming and it boosts to this natural climate change. That's why we call the climate change. Actually, climate change is a natural process, but we boost by our causes, our action, our activities to the global warming. That global warming the boost to the climate change to faster than the nature process. So in here, I would like to highlight about this only basis concept. And here, this is also the some warming question and some funny question for you. And here, which side they are living, there is a polar bear and the penguin. Actually, this is a very kid question for uh, very basic
South
question.
penguin.
So yes,
South penguin. Penguin in the south.
yes, yes, sure. So uh, regarding this question, the answer is this. Uh, in the North Pole, the Arctic region, there is only polar bear and some other species, like a fox, wolf, and like this. But in Antarctica, it is penguin are only one species, the giant species. Other the species and the correlate also the around the Antarctica. So firstly, also the one main question. This is a very basic question for our earth science. We already know about the atmosphere is all gases are occurring in our planet. It is an atmosphere. And the pattern of weather condition over many years is called because the climate. Climate is a series concept of the weather. So that's why weather condition over many years is called. The, another question is that the increase in average temperature or the Earth atmosphere referred is by scientists as it is called the global heating, otherwise global warming. That's why this is a basic definition of the global warming. It is just increase in temperature or our at average temperature. The most of our human activity are the boosting this average temperature to higher than the normal. Normal mean the last century, the 1900 or behind that, maybe 1800 years or so. Last centuries. During the last century, global our average temperature is steady, almost steady, and not too much cake. But after revolutionary or for our this year, the after 90s, there is a revolution. So many revolution, IT and machine, so many. That's why based on after this, our average global temperature is increasing significantly, and that's called that we call global warming and global heating. In here also, the which gazette is the atmosphere, the most producing about from these fossil fuel and the glycol. We already know this is a carbon dioxide. Carbon dioxide is the major gases for the interaction about our climate. because in ocean and our land, these are the air, sea, land interaction. In this interaction system, the carbon dioxide is one important gases because the in the oceanography, the carbon dioxide can be the influence to the ocean acidity also. This acidity can be impact on the ocean warming and our one ocean warming is a boost to our air-sea interaction. So the weather can be impacted by carbon dioxide. Not rightly, but it is very important for the climate. And another question is, which of the following sector does not contribute the greenhouse gas emission? And here the four is transportation, fashion, farming. But we can be consider fashion. What fashion is impact to our greenhouse gas emission. Actually, all the sectors are emitted these greenhouse gas very few amount. Sometimes in my previous research paper about climate change impact on COVID-19, that paper I already mentioned about this sector, which sector is most emission about the greenhouse gas to our atmosphere. It is transportation. And also fashion also emission very some few amount and farming also. That's why they all do emission greenhouse gas to our atmosphere. And also there is a direct and indirect impact on the climate change on the health. So nowadays after analyzing most of the research is already finished in the climate change and our weather system. Many research paper you can be seeing online also. So nowadays, most of the scientists are shifting to the connection with the climate change on Earth. Maybe our previous former vice president, his research is very nice. He want to try to show about the climate change impact on the health on Africa region, especially for malaria. So this is also very good research title and idea. So nowadays, most of the scientists are finding about the climate change and air problem connection. Nowadays, this is a popular topic currently in our research society. So as is we already know or about the connection with the climate change. And the last question is, what are the gases called the frequent threat in the atmosphere and heating the planet? We already know this is a greenhouse gas. Okay, this is after some few years behind by 2000. So most of the global governance are notifying about the scientists finding. Scientists are finding our global warming and climate pattern change. At the time that they didn't know about the average temperature is getting 1.5 to 2 degrees Celsius. After 2010, most of the researchers are suggested frequently about this issue. At the time, the UN, United Nations are organized about this Paris Agreement to focus on our climate change problem. So since that time, the climate change topic is popularity and most of the global governors, like a big country like China, USA, and Russia, and European Commission, they already get the agreement about in 2030, after next 50 years, they will be stopped and they will be maintained the warming 1.5 degrees Celsius to our global. They will be limited. However, actually we already know they cannot. They didn't do. They didn't follow this agreement, and they make the continuation the emission carbon dioxide and other fossil fuel burning also. That's why now they try to limit it to 2 degrees Celsius because after COVID-19 our global warming is already reached the 1.5 degrees Celsius. So currently our global warming is 1.5 degrees Celsius about normal. And that's why that they try to limit at the 2 degrees Celsius again. And maybe 2050, they target. So these are the just general about that. This also the sun-based knowledge about the carbon footprint. It is a study of the carbon. Where is the carbon are coming? There is a lot of, including the one of my people also review about the digital hour. Now today our meeting also making the sun emission of the carbon dioxide to the our atmosphere because we are using electric device and the mobile phone. Those power consumption are also the impact to the carbon emission to our atmosphere. So these are the just question for you, the young people, should take, because we should take care about the everyday about our emission. Our daily life should be changed in future. Later, I will explain about the one important by your age. Okay, this is a basic concept of our climate system. These five spheres is working together to occur the climate and weather pattern in our atmosphere and our Earth. So these five spheres we already know about the atmosphere, cryosphere, about the icing and glacier, and maybe the North Pole and South Pole and our Tibetan Plateau also. And the lithosphere is a synthesis and our Earth surface, and biosphere is a living things like a malaria, mosquito, or something like that, and hydrosphere, water. So these five spheres are working together to occur our climate system. This is the basic concept. These are the nature. In the right side is a natural process. It's in here, the left side, we boost this natural process. We are involving this natural process and we making the sun boosting. Maybe our action and activity can be reduction, but also that we also the emission. There is a negative and positive impact to this natural process. That's why we had to analyze which activity and action are positive feedback to our climate system or what is a negative feedback to our climate system. If we know this, we can be making the rules and policy in future. Nowadays, most of the scientists already define which activity or action need to be stopped or the which activity should be need to be boosted for to maintain our climate system. So in climate system, the one thing is a major key player because we already know the sun, our solar system. If there is no sun, there is no weather, and maybe there will be weathers, but the normal, not like a normal weather. So there is no sun there. There is no weather like our weather. So that's why sun insolation, otherwise sunlight is very important for our climate and weather system. The solar radiation energy is the primary energy for our climate system. And according to this natural process, these sun energy, solar energy are the starting point of this climate system. When the solar system, solar radiation touch to our upper atmosphere, since that time, there is a studying the activity ongoing and ingoing and outgoing. There is a in and out activity studying since the first layer of our atmosphere and the ozone layer also otherwise and the surface video. So these systems are studying the circulation and the occurring, it boosts to occurring the climate and weather pattern. So these are the basic concept of our climate system. So when we see about the greenhouse gas, this is a very bad basis example for the greenhouse gas impact. And here you see that when we are parking our car under the sunlight, maybe in the daytime, in the noontime, afternoon time. So that heat outside temperature and inside temperature in the car is very totally different. Maybe most of us already experience about this. Why this occur? Because we are making auto unlock and mirror unlock already. It's like glasses. It's like a spear, small spear in the car. So when the sunlight solar radiation are inside, putting the inside to the heat, especially for heat is enter to the car, and it are the trapped in the car body, inside the car. So the heat cannot be outside. It called the greenhouse gas effect. When we are considered to the like this system, if there is no heat, the not going back to the outside or other places, not I mean the not separate to the others, not distribution too much one area. It only the trapped in the small region, like our pole side or glacier side. So it will be something occur because the system will be breakdown due to this effect. That's why the greenhouse gas should be the contributes equal quantity in the everywhere. If not, that there will be something will be happen occur. That's why nowadays our extreme weather event pattern are due to this solar radiation impact and the greenhouse gas impact. Solar radiation is a just natural process, it's a normal, no problem. But due to this greenhouse gas effect, that this solar radiation are the changing, and that the energy balance is not too much balance, and balancing and making the extreme weather events. Okay, about our this energy balance, as I mentioned previously, uh, the energy balance is very important. Our system everywhere should be, these energies should be balanced in everywhere or the up. If not, there will be extreme event. This is a very basic concept for the climate. If you want to know the more detail about this event, according to the time limitation, that I don't want to play with it is a little bit long explanation about this video. You can be watching this video later. I will share my PPT is later. So this also, we already know that solar radiation impacts are and different and balance according to our Earth surface. That's why our Earth surface also play in the major, because this is a secondary part. First part is solar radiation is a major key player. This solar radiation energy are coming into our Earth atmosphere. Then our Earth surface are receiving this solar radiation. But according to the differential of these our atmosphere, like an ocean location, there is a deserts, mountain range. This is the topography are totally different in everywhere. That's why based on the topography impact, there also energy imbalances are occur. So you can see that this is the general temperature distribution for our atmosphere, about our sunlight. In here, solar radiation are imbalancing in the pole and the tropic. Tropical is that's why too much higher temperature than the polar side. These are the normal balancing. And here, nowadays, we are making this balancing pattern to imbalancing by our anthropogenic activity and action. That's why the extreme occur and our human activity and anthropogenic climate change are occur. So then another thing is now this topic also in maybe in next year or coming few years, it will be hot issue and hot topic. Currently, I also study a lot of things about this. it can be one kind of parallel climate change study. So it is study about the Earth orbiting system because the Earth orbiting system also changed. Actually, it is also nature change process. However, nowadays, according to the Einstein and Stephen Hawking and some the very famous scientists, they already mentioned that our universe are expand, but the time scale is too much, maybe million year or billion year. However, the current our galaxy Milky Way, our universe system is uh, we cannot catch it about the every detail like our Earth atmosphere because it is outside of our uh, Earth. So the NASA stay to study about this variation. However, nowadays the NASA data can be supported about this at the orbital system because it just study about our orbital system to the sun. So they trusted that these orbited are the shifting to the from the normal pattern, and it also play a major component as to the climate change. So in here, this Milan-Covid cycle is a very popular nowadays, and most of the researchers are trying to study about it here. You see that in this animation, this steady the ring is our normal orbiting system, but the orbiting system are changing by time like this due to the solar orbiting our universe system. So nowadays we are trying to define which state we are staying and how much it will be shifting from the last 100 years ago. So because I already mentioned after 90 after revolutionary, there will be the studying the climate change. Otherwise, after actually definitely maybe after 1920, after 1920, our climate is totally significantly changed. That's why. So we are considered that we have to study after 90 how much of it the system change because it will be impact. It also impact to our climate system in one part. That's why nowadays the researchers are trying to study about this. That maybe that if you are interested, you can study about this Milan-Kobe cycle and our climate change relationship. So that's why, according to the previous three major posts, our energy flow are the various and those solar radiation. For example, in here, this figure is an example. Solar radiation is incoming. We support that 100%. Okay, 100%. If they meet the high layer cloud or low layer cloud, according to the cloud albedo, I will explain about the albedo later and next slide. According to the cloud albedo, 23% or maybe nearly 20% are re-outing the outer atmosphere. Then 90% are absorbing by atmosphere. That's why 49% are reached to our Earth surface like this. These are just example for these solar radiation are working with our atmosphere component like a cloud and the other aerosol buzzes like this. So for detailed value, there will be you can study in this lens also. So about the previous slide, I already mentioned about the albedo. So the albedo is we already know about the cloud albedo. One, we are making the modeling, maybe the initialization and parameterization state that we had to define this albedo value also. There will be if you are playing this albedo the same value, our modeling output generated modeling output can be changed because this albedo also taking the important role in our climate system. That's why nowadays we study about the polar region climate. We also consider about the albedo system because white color, white color. Otherwise, these ice sheet and glaciers are the very high albedo because white is reflected maybe nearly the more than 50% to the outside atmosphere like this. So we already know black body in satellite meteorology. We already know black body are absorbed or light, so that there is no back radiation outside again. So like this concept, white is at 100% cobalt and the other are nearly black color are absorbed too much and then no back the radiation like this. Based on that this concept, our Earth surface albedo are they also different and it also play that climate system. These are the some example here. If there is a glacier and like maybe the white color is simply white color is 90% reflected, and the water color brown like this according to the based on the color of this area, the solar radiation reflection is percentage will be different. Based on this, the natural climate system are OGA. That's why nowadays the some researcher about the urban climate change, because the urban is most significant clear for the local regional climate change. So that's why urban and vegetation, otherwise the forest area are totally different in climate. Maybe you had already had experience. We are living in the downtown, so the temperature is significantly warming. When you are driving out or walking out to your town, and there will be forest, so the temperature is really comfortable to you. So most of us already experience about the temperature changes. This also this is the same concept about this energy balancing system. So these are also the feedback about each surface by percentage. It is by the ATE monitoring assessment program that they suggested these percentage are there. This is the literature percentage. They already study about this, how much reflected due to the which variable, which surface. So as I mentioned previously, these climate change impact are there will be positive feedback. Also, there will be negative feedback. The positive feedback is simply there is cooling temperature. There is we suppose that there is a very less solar installation. There will be ice will be growth, increase in albedo because the ice are white to increase in albedo. Then the less insolation as well. So they are like in the circulation like this. If there is if there is more solar radiation, there will be warming, and ice will be melting. So albedo will be decreased. There will be more insolation as well. So you see, we can see this is a cycle, natural process. It's a connection each other, and one influence to another. Another can be influenced to this one also like this. So these are our natural cycle. So about the negative feedback. So negative feedback also like this. If there is warming, increase in weathering. So weaker greenhouse gas and cooling. So after cooling, you can see this process. These are we were putting the one side in here. I will explain later. This concept, these cooling are also bring back to this concept again. This answer again. That's why positive and negative feedback are working together. However, in here, we can see weaker greenhouse gases and stronger greenhouses. In this natural process, we are boosting to these greenhouse gases. These are the currently natural process. We didn't do any action on this process. But however, nowadays we already know we are boosting this greenhouse gas more than the normal. So what will be happen? This weaker will be stronger and it will be warming. Warming will be in here. ice will be melting and decreasing ability, more isolation. Then the warming. What will be warming happen? Warming will be increased weathering. These are the like these are connection each other in the system. That's why the and here you see the which process we can be managed on it. Only the greenhouse gas. We cannot control the solar radiation. We cannot control the our Arctic region air surface like a glacier. We cannot broken down the ice path. It's too big. Antarctica is like a continent, a very big continent. So we cannot manage on it. So which one we can manage? We can manage on greenhouse gas, and this also important. We also boosting this one also. That's why we are focusing on the greenhouse gas impact. So yeah, I would like to the suggestion for the young student and the researcher. And here you can be seeing that this climate tipping point, we call the climate tipping point. So monsoon system, tropical, it is including the most of the field, like this is the oceanography study, this is the polar region study, this is our atmosphere dynamic study, monsoon system, and also this thermocline circulation is also ocean study. Like in our climate system, there will be connection activity, connection system each other. There is a lot of system. Because nowadays in our campus, we are study one thing. Every student are study one thing. So if we can connect each other and we can study the connection the two system, that it can be it will be good output for our research societies. That's why if you want to try to study, that you should connect this one like this one. So nowadays, the most of our meteorological students always consider to connection with the regional climate to the El Nino Southern oscillation, right? So actually, El Nino Southern is only one climate tipping point. There is a lot of things you can do that you have to do, you have to task. For example, currently me and this Aminu, the vice president, we two together trying to connection our monsoon system and RTC ice. We already making the one manuscript and already the submitting. So you can also do this climate tipping point connection in your study. For example, if you are from the oceanography, this Atlantic thermoclimate, how much these are influence teleconnection with monsoon or this Arctic region like that you can study like. So that's why I would like to suggest that you should do this kind of connections, teleconnection study in future. So after basis of the climate change and the climate interaction explanation, I would like to introduce current climate outlook by our IPCC. IPCC is the Intergovernmental Climate Change Panel that they are working together about the climate change. This is the 2023 report results. I would like to or highlight about their finding. So currently, I already explained about this sphere, 5 sphere. Actually, in here they study 4 sphere. In these 4 sphere, there is a lot of change you can be seen after 1950. So firstly, let's check in the CO2 concentration in the atmosphere. It is also 1 million. That is also the increasing, and here precipitation is actually the precipitation stay the northern hemisphere. It is significantly increasing. Northern hemisphere is not significantly increasing. This is a vice versa. Sometimes increasing very significantly, 100% change sometimes, but it's also decreasing again and the increasing again, up and down, up and down. But in here, northern hemisphere is significantly changed, maybe after 2000 in here. So in here, I would like to ask why northern and southern hemisphere are different. So anybody ask and answer this question? Why these northern and southern hemisphere are different in the rainfall trend? Anyone ask? Hello? No one? So actually yes. Yeah, you can answer. Okay. If there is no one, it is very simply I will move back to here. And here where is equator? Equator is here, right? Here. So equator is here. Equator is here. So you can be seen which hemisphere had more continent. We already know that our northern hemisphere has more continent than the southern hemisphere. That's why as my previous explanation, in our continent, the topography are always changing, and more emission, more warming because the United States and also northern hemisphere, China also in northern hemisphere, Russia and European also. Most emission countries are in the northern hemisphere, and also, there is a land surface changing every day. Okay, but in southern hemisphere, there also are the region, very big glacier, and the ocean are always steady color, one color, so like a blue. The solar radiation absorption is mostly constant on the southern hemisphere, and the albedo also nearly constant. That's why the southern hemisphere is up and down, vice versa, no trend. We can say no trend, but in northern hemisphere, it is an increasing trend. However, in southern hemisphere, sometimes it will be a sharply increasing and sharply down because this is due to the normal process. So there also glacial mass loss also increasing trend. Global surface temperature, this is we already know about the temperature increasing by time. And also sea level also rising, also sea level rising. And here, I would like to explain about the global sea level rising issue. Some researchers are suggesting there is a more mountain in the cryosphere. Some researchers are suggesting ocean is maybe because if there is a more warming ocean, more expanded the volume, right? So like a temperature and the volume, the equation according to the ideal gas law, there will be more warming, more expand the molecule. So that's why ocean is increasing volume is by the more warming. They state that are going about this issue. But however, the global sea level is a real increasing by observation data. Also, ocean heat content also this. That's why these two can be connecting each other. That's why some researchers are suggesting this ocean are volume up is up by heating. So according to their suggestion, that all are increasing. So that's why our climate change boosts than the normal. Maybe according to the normal pattern, that maybe in next 100 years there will be temperature increasing is 1 degree Celsius. These are the normal process we support that. Only 1 degree Celsius will increase in after 100 years. However, according to our anthropogenetics, our action and our activity, within that 50 years, there will be 1 degree Celsius increase in like this. Nowadays, our atmosphere temperature is already increasing 1.5 degrees Celsius than the normal. Now we are trying to maintain the 2 degrees Celsius. To the measure and to the study this climate change, this IPCC are trying to make the scenario to pay up the model based on these data, observation data. These observation data, they will use the drivers, emission, concentration, climate project, geophysical impacts, and the spatial level human impact. They are waiting at the model. The previous simplify is just involving very few data, but then after simplify, the simplifies are involving, they also consider about the social economic pathway. It means that they are they input the more than the how should I say that they translate our real world activity, including our GDP, our daily work duration, our daily study duration, our daily transportation system, and how much emission by transportation, and how much this GDP income, because the GDP also impact on the climate system. They support the science study. This is the very detailed. So based on this, they translate all activity of us, our including climate science, our social science and economic, they translate all data as to the numerical and they making the model. So for details that you can be study in IPCC website. And here I would like to explain just a basic. These are the contribution model set up for this IPCC SIMI and SIMI-5 project. Now they are trying for SIMI-7. These are the center of the modern day and center of central region, China, Norway, US, Canada. Most of the institutions are involving in this project and they're trying to contribute that they are finding and they are modeling results. These are the modern name for the maybe the goddess. Most of us we already know about that these coordinated regional climate downscaling experiment. Okay, these model they working together for our climate system. So these are the server from the I think they're from Germany. Yes, Germany, and these are the center or one modern center. If we don't have this facility, that we cannot generate a modeling. So our personal computer cannot generate this model because it's too big and too much complication. So this is just a general knowledge for this. And here, as I mentioned, that these simulations are involving all these data, and they are making the building up the model output. Actually, the in simulation that you can be download, for example, rainfall data. Okay, next 300 year, 2000 to 2300. Okay, baseline is a 98, 8050 to the 2040. Okay, how they are making to get the rainfall? They consider all concept and making be at the equation about all these together. Then they are projection that they are output. So after modeling, they are trying to understand the sustainable and the mitigation process. And here I don't want to explain detail about what they are doing, but here the which data are involving on this, you should know this physical water, about the agriculture and livestock, fishery. Some marine students also study about the fishery like this. And these are the important about the hair, and diseases, and mental hair and the split, and these are about the hair sector. And this also settlement urban study and biodiversity and ecosystem. These four major fields are involving and consideration to sustain, share, and sustainable. because these sector, all these sector are actually damaging due to the climate change in our nowadays our world experience about this damage, these sector damaging by climate change. That's why they focus and they suggest about this be study. And what are the impact and the driver? The driver impact to the this, but actually these four setup come from this driver. Okay, so these driver now we already know about the precipitation, heavy precipitation impact to the previous four setup. So oh, in here they are suggestion by their confidence level. So rainfall is not too much significant for about the increase, but however, glacier retreat and global sea level rise is real occur, very real occur, already finished. The sea level is real rising and glacier melting is already occurring. That's why these two are already definitely sure. So they are trying to maintain sustain these two things and about the precipitation. Also, other are also medium confidence level. They stay steady to the to reduction that these activities. So in here, my first previous slide I mentioned which year born will be experienced in our real global climate change according to the projection. If you are born within the 1980, if you will be you age to the 70 year, you will be sure experience about the median climate change. Median. This will be more warmer than but the median impact. But if you are born after 2020, you are definitely sure the very severe climate change in your era age. They are making the projection by the human ages because if I will explain about in here this one. So these are the very low, intermediate, high, and very high. These are the scenario we support. They support in their modeling. If we are maintaining on the 1.5 degrees, it got the SSP1 scenario. Sun climate science, we already know about this cohort. And also, if we maintain in the 2 degrees Celsius, it's also SSP1. This is the lowest one, and this is a middle way. Middle way is it means that simply that we are not increasing our emission or our greenhouse gas emission. We're not increasing, but we stay emitted nowadays rate. It called the middle way. This one is we will reduction the emission. This is a low scenario. If high is we were we never focus on this. We don't care about everything. We continue increasing our emission yearly. It will be the very high scenario and it will be impact very high. In here, we can be seen. This is the annual temperature the annual hottest day. It means very hot day in a year. And this is the climate change and this is the precipitation. What does they mean? The very extreme rainfall day. So you can be seeing that if in 1.5, this first column is a 1.5, it's not too much significant change, right? The color shaded mean that the percentage change, green are the positive change and the brown are the negative change. And here and red are the positive change and the blue are the negative. No, this means it's just positive only. Temperature is only positive. There is no negative change. So and here we can see. Now we are talking about the 2 degrees Celsius. If we can maintain in 2050 to the 2 degrees Celsius, we didn't sure about that we can limit it 2 degrees Celsius till now. Because according to the projection, if we continue this state, no reduction, it will be 3 degrees to 4 degrees Celsius. So we will be occur this weather activity in future if we didn't do any reduction or the sustainable. If we sustainable in 2050, that we will be experiencing this. This one is already gone. We already passed this one, so we can bring back. We cannot bring back this weather in current day. But we can limit that to this one between this and these two column, first two column, so that we can be seen like this. So according to this figure, the most impact region is you can be seen tropical region. Why tropical region are the most because I already explained that solar radiation and balancing because tropical region is more absorbing the solar radiation. If there is activity, anthropogenic activity, no forest, more urban, and the ocean more warming, that they are weather extremely even extremely day by day and year by year. Yeah, that's okay. If you are from the tropical country, you should careful about this more than the other people. So these are the similar results like these. These are the weather parameter. These are for the species loss, for the social and the biosphere. This also our species will be lost by this climate change, global warming, 2.2 degrees Celsius. And maybe in Africa, there's no safari in future due to those climate change. Maybe the animal behavior and their evolution will be changed because our human also that we had the system adaptation system. We can be change our body system by our environment, but we cannot catch at our rate of the adaptation. That's why that is also important for our health problem. So this is the hair human risk. I already mentioned. This will be more, the whole year will be very heat and humid in the tropical region. So these are the projection results for the hair and humidity risk, and also the agriculture sector and fishery livestock sector. We can be found these different activities and the different percentage. And here, I would like to explain about these time series. This is now the 2050. This is the baseline of the simulation model. And according to their scenario, we are currently in this state, so low state. It means that in 2050 and 2100, if we can reduction or we limiting our temperature in 2 degrees Celsius, we will be steady in here in future, not too much climate change. But if we cannot sustain and we cannot limit this degree Celsius, we will be experiencing intermediate or high level according to our reduction volume. So these are their report. So in here, I don't want to, these are just for the suggestion for the policymaker. It is too much literature, so I don't want to detail about it. It's including about the wildfire damage and the sector by sector, their suggestion, and also all society. And here, these are the targeted. In 2023, I already mentioned they cannot get the target 1.5 degrees Celsius. That's why they increasing to limitation warming to 2 degrees Celsius. So and here, if we are still, this red line is our actual one. So currently we are currently like this. If we didn't do this line starting from this, we cannot limit this two. We will be continue like this line. So They said about the CO2. It means that CO2 we emission and like a steady current emission volume. We will continue like this, and we will experience in the percentage in this. These are also about the other gases and CO2 and CH4 methane emission also. So that because of these also methane also greenhouse gas also, or we are targeting not only focus on the CO2, we also focus we should also focus on other the greenhouse gas also. The target is to reduction the greenhouse gas. But the CO2 is the most important because in greenhouse gas CO2 is a more quantity which influence to the our climate system and ocean system. So the if how we can mitigation and the sustain adaptation for this previous explanation. If we change in here, these are the suggestion. But if we change for the solar panel and the wind, and if we use energy from these two, it means that there is no cost. How much there is no cost, how much we can their projection. This figure is explained about projection, but if there is no cost, we will be certain how much we can be sustained, we can be reduced, how much we can reduce. And if we use the 100 or $200, how much we can be reduction like this. They are making the for the policymaker. The best thing is the wind and the solar system, electricity, and this is a very vast tool thing for to reduction the fossil fuel burning electricity outputs. So their suggestion like this. Okay, others that are also like this. For detail that you can be read this their report. They will be writing detail about it. So these IPCC are suggestion also their projection results and also the suggestion for the policymaker, and they also suggest how should they do. These policymakers should do. They already suggested. If those government didn't do, it is not about their concern. About our scientific side, researcher side, we already explain and we already study about to them. They should be do something on that. That's why the United Nations are organizing and boosting to the global government to focus on this climate issue. So this is a global trend, and thank you for my session. Aminu, the Vice President, will continue for the regional climate change trend. Thank you.
Okay, can you see my screen? Hello.
Yes, I mean we can see you screen.
Okay. Good evening, everyone. Here in China is night, as you guys know. So if it is afternoon or morning where you are, I'm saying hi to you. I'm going to look at the current climate outlook together with you guys. That is the regional climate impact, as introduced by uh, Danish Vice President and also Cao, our former president. I don't have to introduce myself again. But I have a question for the audience regarding what did you guys understand about the Cao lecture? Anything what can you say about the class? Is there anything? What do you understand about the no response? Okay. Okay, so no response from the audience. Okay, so quickly, I'm going to look at the first of all the introductions and also the Arctic regions, then Sub-Sahara Africa regions, then Asia region, then North America, Europe, and summary and conclusion. This is what we are going to be discussing within a couple of minutes. For the introductions, I think for the climate change, Cal has already explained all what you need to know about the climate change, and climate change issues is not new to most of you guys. So I believe almost everyone has some understanding of what climate change is and what it's all about. But what I'm going to say here is that climate change is a global phenomena with region specific. It is effect dependent on the region, it is the geography, the economy, and of course the social factors. Some places experience more of drought, while some places experience more of flooding, some places experience more of wildfire, some cyclones, and some heat waves, while some places like polar regions, ice melting. Understanding this regional impact is very important for tailoring mitigations and adaptation strategies. Just to take you back regarding the carbon dioxide, Kev has already discussed about this, but just to add more details about it, we can see that from the year 1950, the carbon dioxide has been increasing so rapidly. Then the temperature change. This is the global temperature change. It has been discussed in the last lecture, but just to refresh your memory, this was is a warming strip developed by Professor Hawkins from the University of Reading, United Kingdom. I was able to work under his supervision. He's one of the good professor in the university, and he was able to create this warming strip to show how the temperature is changing over the years. And the good thing about this warming strip is that you can be able to see how the temperature of your country is changing, and of course, some part of the country. It depends on the availability of the data. So the website is, if you want, you can easily Google the names here, and you can be able to see the more details about this temperature change. This is just a global temperature change. The bar chart, you can see it has been increasing so rapidly from the year, let's say 1980 something to 2023. The temperature has been increasing. And of course, the global carbon emissions based on the countries. We have seen that China, United States, Russia, India, they are developed countries and they are among the major contributors to carbon emissions. United States appear to be the highest country in terms of emissions, followed by China and also Russia, and lastly, India. Then let me take you to the Arctic regions. In the Arctic, climate has been changing, has been also affecting the Arctic ice. It warms about twice compared to a global average. And in some research, they mentioned that it's warm about 4 times compared to global average. This has resulted in dramatic reduction in sea ice with severe implication for wildlife. For example, you can see that the polar bear in the Arctic, they have been suffering due to the ice melting. This is the map for the Arctic. You can see this is the Arctic regions. And of course, the loss of ice also contribute to global sea level rise. Then temperature change in the Arctic, as I just said now, we have seen a substantial changes in the temperature change over some years. Let's say from 1940 to 2023, we have seen a rapid increase of temperature in the Arctic, and 2023 appeared to be the hottest summer in the record. Some areas in the Arctic that appear to be more warmer is somewhere around Alaska and Russia and Arctic cycles, then off Canada. See, and this figure is from IPCC NOAA. If you have time, you can go to the IPCC 2023 or NOAA site to have more details about this. And the average monthly Arctic ice extent from 1979 to 2024 indicate a decreasing trend from the year 1980 to 2024 in the Arctic due to the climate change. And if I'm to take you back in 1985 March, you can see the Arctic regions, and also by your right hand side in the same month in 2021, you can see another image indicating the same locations. For example, if you look at the Beaufort Sea in 1985 and compare it with the image in the same month in 2021, you can see rapid changes in the two images, indicating how Arctic ice is melting. Then this also contribute to the global sea level changes. We can see from 1880 to 2023, there has been changes in the sea level, which if you look at the trend, we can say that it's actually increasing so rapidly. Taking you to the sub-Sahara Africa, over the sub-Sahara, that is entire Africa, Africa face heightening vulnerability to climate change because of reliance on agriculture, which is highly sensitive to changes in temperature and precipitations. And increasing temperature and shifting rainfall patterns threaten food security, as well as the livelihood and, of course, water resources. Temperature in Africa, based on WMO, World Meteorological Organizations, indicate a increasing trend. You can see from 1900 to 2020, there has been increasing at some years and decreasing at some years. But if you look at the trend in average, you can see that it's actually increasing over the years. And for the precipitation changes, this is the first figure by your left, the precipitation anomalies in millimeter for 2022. And second figure is quantiles reference. This is 1991 to 2022 against 1991 to 2020 against 2022, indicating the blue areas for this picture indicate above average precipitations, and the brown areas like this place indicate below average. This picture is from the WMO website. So this will tell you that in some places they have experienced increase in rainfall in Africa, while some places experience decrease in precipitations due to the change in climate. And this figure is very important. I think you have to maybe pay much attention to this figure. It's very important. It's actually talk about the weather, climate, and water-related disaster in Africa. How the climate change contribute to the weather-related hazard in Africa in the year 2022. The blue color represent flood, and the yellow color represent storm, and the green color represent landslide, and the brown color represent drought, while the dark yellow represent wildfire. You can see for the reported event, 56% out of 80 is flood, and 20% is storm, and 4% landslide, and 17% drought, while only 3% wildfire out of 80. And the number of people who have died, that is the death, out of 5,000 people in the year 2022, flood, 43% was died as a result of flood, and 7% died as a result of storm, and 1% died as a result of landslide, and 48% died as a result of a drought, while 1% wildfire. Then affected people, 91% of people out of 110 million people were affected by drought. I told you that the climate change is region specific. So usually in Africa, drought and yes, of course, flooding is one of the major disasters that actually distract the continent. So drought has affected about 91% out of 110 million people, and 7% is flooding, and 2% is storm. Then for the economy's damages, 92% is flooding out of 8.5 billion US dollar. 92% is flooding, while 8% is drought. And yeah, 8% drought, 92% flooding. You can see from this figure, you can see that most of the disaster that we're experiencing in Africa is drought and flooding. This figure is from WMO. And the key message here regarding the climate change issues in Africa, temperature increase is accelerating. Extreme weather wasn't put insecurity, of course, displacement and conflicts. Agricultural productivity is failing due to the drought, and adaptations financing is insufficient due to the economy standard. Losses and damages are rising. Early warning must reach everyone. Then, out of the effort that the African governments are doing to mitigate the impact of this climate change is that more than 50 countries have now submitted their national determined contributions, especially on the issues of agriculture and food security, water disaster risk reductions, health, and others. Then, of course, agriculture There is some kind of suggested crop that is compatible with the changing climate, and also water management, implementing efficient irrigations and rainwater, and also coastal protections, disaster risk reductions, like early warning systems, then renewable energy. Of course, the government is trying to invest, and of course, people are also engaging themselves in using solar and wind energy, and of course, to mitigate the impact of climate change. Then forest conservations, and also there are some policy of the governance. Then, moreover, there are also a public awareness, which is educating the public and involving communities in adaptations effort. Then urban development, health, and also some contribution from the African World Bank. Is all this is the effort to mitigate the impact of climate change in Africa. Then, if we come back here in the Asia, uh, we can see that Asia, especially South and Southeast Asia, is grappling with rising sea level and, of course, monsoon changing patterns, increasing intensity of tropical cyclones. Coastal megacities such as Mumbai, Bangkok, and Jakarta are at high risk of flooding. This is the major climate region of Asia. You can see, I don't have to take you much into this figure, but you're already used to this climate, uh, the climate of the regions. The rainforest is around these areas, and the green grasslands around this India, and also humid subtropical East China, also a desert in this area. Uh, Rising sea levels. Here is a question which said that which countries are most in danger from rising sea levels? Can anyone say something regarding these questions? Are you with me? Hello, guys. What do you think about which countries here in Asia are most in danger from rising sea levels?
Because most of the country are in the ocean, mostly Iceland, like an Iceland country.
Mm.
So they had the long coast there.
Yeah, you're right, Mr. President. Thank you for your contributions. Yes, as you said, and of course that depend on the how the temperature change. You can see that the blue dark line is 4 degrees Celsius, and the 2 degree Celsius is the light blue. With 2 degree rise in temperature, 64 million people in China with this one, based on the 2010 populations, will be living in areas submerged by rising sea. When there is increase of 2 degrees Celsius based on 2010 populations. But when there is increase of 4 degrees Celsius, uh, 145 millions will be living in areas submerged by rising sea. And of course, the same thing here in India, 20 and 55, and Bangladesh, 48 million people for based on 4 degrees Celsius, and 12 million people based on the 2 degrees Celsius. Then Vietnam, Indonesia, Japan, etc. And this figure is from the World Economic Forum. If you have time, you can go there and have more details about this. So, where most people are affected by rising sea levels by the year 2100. This is like a projection from the Statista. We are focusing on Asia, not Africa, not Europe. So if you look at the Asian countries, you can see that between 10 to 50 million people is in China, and some countries in South China, you can see, and between 1 to 9 million is around this country and also this country. So this is like a picture projections. And this is a new finding by Jing. The paper was recently published in this 2024, I think last 2 months, on the global distribution of annual person's exposure to tropical cyclone between the year 2002 and 2019. And what the figure is just saying is that it's explaining the numbers of people who are exposed to tropical cyclones in Asia. But the Atlantic coastal North and Central America, which is A, and also the Caribbean, which is this B, then the Korean and Japan's, which is C here, and coastal Eastern Asia over here, then Southeast Asia over here, and of course Eastern India and Bay of Bengal over here. And the blue line is a storm tracks. You can see a very light line is a storm track. Based on their finding, they discovered that more people are affected by tropical cyclones in Asia than any other region, because they have compared also some countries in Atlantic coastals, North and Central America and Caribbean, and also they look at the Asians. So they conclude that more people are affected by tropical cyclone in Asia than other regions. If you have time, you can also go through the paper, and of course the link for the paper is in the end of this slide. I will share the slide so you can be able to see by yourself. And moving to the monsoons, Asian monsoons variability. We have about 2 to 3 monsoons, I think. We have East Asian winter monsoons, we have Indian monsoons, of course, we have East Asian summer monsoons, right? Is it 3 or more? Do we have anyone more? Any contributions? Okay, so I think this is the major monsoon we have here in Asia. So looking at the variability, this figure indicate that because the East Asian summer monsoon is one of the monsoon that is very critical here in China. So I consider to bring it and discuss about it. You can see the changes for the monsoons. This is the monsoon index over some years from the year 1980 to year 2022. You can see it has been changing over some years. And the adaptations effort that the is being made here in Asia. Natural-based solutions, and of course, urban resilience initiatives in corporations, then adaptive flood management, sustainable transport strategies, energy resilience adaptations, financings based on the, if you want more information about this, then this is the link. You can just click on this link, then you'll be able to read about more details on this. Then adaptations, financings. Then for the North America and in Europe regions, I think I haven't put much information about this. I consider to look at the two regions so that we can, because of times. But if you have times, I have a link here. If you have time, you can click on this, then you can be able to see more information about the North America um, climate change impact and also the Europe. But in a nutshell, in North America, they have been experiencing frequent and severe wildfire, particularly in the western United States and Canada, which was driven by higher temperature and prolonging drought. The Gulf Coast faced increasing hurricanes activities, while in the Europe is, of course, experiencing a range of climate impacts, including heat waves, which have become more frequent and severe, which also affect health and agriculture, as well as energy supply. And in summary, maybe I'll ask someone to help me summarize what I just said in this few minutes. Can someone help me? Not based on this slide, not based on this slide. Can someone help me just summarize maybe 2 or 3 slides of what I just said now? Can someone? Anyone? Are you with us? Anyway, so in a nutshell, the most important part of this conclusion is uh, to I can see someone wants to talk. Okay, the current climate outlook, of course, underscores the urgent need for comprehensive and coordinated global actions to mitigate the pressing issues of climate change and also, of course, to adapt to its inevitable impact. While challenges are significant, there is also an opportunity to transition to a more sustainable and resilient future by investing, by reducing greenhouse emissions, enhancing adaptive capacities, and investing in renewable energy. Of course, understanding this regional impact is very important for tailoring specific intervention that can effectively address unique vulnerabilities and needs of different locations and ultimately contributing to global resilience. And this is some of the reference. If you have time, you can go through them. Thank you very much for listening. If you have any questions, we decide to give you guys 20 minutes if there is any questions, so you can be able to ask questions, and the two speakers will be able to try our best to see how best we can answer your questions. Thank you very much. Any questions? If maybe you feel uncomfortable to speak, maybe you can just drop your questions on the chat so we can be able to address your questions. You have 20 minutes to ask any questions you want related to what we discussed now. And in addition to people who have interest to join our, I don't know, the teleconnection issues, Mr. President, our former president has emphasized on that. In case for those who are guys who have common interest, you are welcome to join the club. Maybe as your second research if you have already decided on what to do with their supervisor. Okay, so I can see no any question yet. That means we have actually done a very good job with our former president. So I will hand it over you guys to the Mr. President, the current IMSA president, to take over. Thank you very much, guys, for your times and for your patience. Thank you.
Thank you very much, Aminu and our former president. Yeah. So you guys have any questions? I think we have 15 minutes left. So if any questions, you guys have any questions, you can ask from our facilitator. So meanwhile, I will share the attendance QR with you so you can mark your attendance. I think one guy is asking about a question regarding drought and CO2 currently increasing, but they have inversely related. What is the reason behind this? Kemal is asking about this question.
Yes, I would take over this question regarding question. Actually, the drought is regional impact, not the global scale. Also, it is only the regional, but the CO2 is not the regional impact. Uh, for example, China emission a lot of CO2, the higher rank in the world. U.S. and China are taking the rank one about the CO2 emission in each year, vice versa, up and down. So if CO2 are only the regional impact, there will be no extreme event in our region because, for example, Africa region, there is not too much emission about the CO2. But because the CO2s are actually the global scale, the variable, that's why the regional impact drop and the global impact CO2 maybe the inversely or something. The increasing is yes, real increasing trend. The sun region are drought, increasing drought day, and the sun dry day are increasing. However, beside the other in opposite other region, there will be more increase in rainfall. For example, our South Asia region, there will be rainfall will be increasing year by year. And that's why in my slide I explain about this solar radiation energy imbalance about the region. Those CO2 are the boosting this imbalance. So those natural imbalance is more significant and more imbalancing like this. That's why drought will be increasing, not directly by the CO2 increasing. It is in middle of these two dry on CO2. There will be some interaction system like your tropical region, topography, and some other near far from ocean or not like this. So based on the other factors, they will be connection each other. However, that your question is we are increasing according to the most of the researcher already mentioned. Draw even in South Africa region increasing year by year, and this is by the CO2 emission. So these two are not basically these two are not saying the scale level. And draw is a regional scale, and the CO2 is a global scale. And that's why they can be increasing. However, maybe inversely.
Is also good, but still it's not opening. Can you see that, please?
Meanwhile, you guys can mark the attendance. I think QR code is working. Is it working?
The same problem last phase.
Okay, if the QR code is not working, you guys can try to scan this one. This one might work. And also, if you have any more questions, you can ask. We have another 10 minutes left. we don't have any questions regarding this session. That means we can. So I think you guys can scan the QR code, right? Is there any issues? Yeah, I see 43 of you have marked the attendance. And in addition to this training, I would like to encourage you guys to join this training program. Also, like, since we discuss about the regional and global trends regarding the climate change, so if you are into more about regional and climate trend, I think you can join this website. Maybe you guys know about this one, NASA ASET website. So if you join here, you can have different like training sessions. Here you can see for the drought. I think one guy asked about the droughts also. So if you are into drought, you can visit this one and register for this event. Like there's a training will be started from July 23 onward. So even they have YouTube channel. In YouTube channel, they have their videos like previous sessions. So if you are into any kind of satellite observations regarding the climate change, I suggest you guys to visit this one. So from there also you can learn something. And at the end, I would like to thank our former president Kia and our vice president Aminu for conducting this lecture series. So thank you all guys for your attendance and your patience. Hope to see you guys in the next lecture. Next Saturday. The usual time will be like from 6 p.m. to 8 p.m. So see you guys there. And thank you for your attention.
Keep quiet.
Mpulira boogera naye ate sigirabye.
This house is so big and pretty. David, do we have to stay in your house?